Hey, Mr. Calbeck here again with another video for Calbeckistan viewers, a place where anybody can learn math. I'm here recording from my home today because it's the weekend, but I wanted to get a video out for those who are working on rational expressions this weekend. I just ask you to please pardon the toys that I've got here at the house. I promise they're my sons. I haven't been the one playing with them, I promise. Again, this is going to be the more advanced version of the adding and subtracting rational expressions. So if you haven't watched the intro video to that, I'd recommend that you start there. I've included the link in the description. For those who are ready for some more challenging kinds of problems, you can stick with me. And again, as always, feel free to pause the video and try them on your own and watch if you need to. We'll jump right in here. Today's lesson will be focusing more on some advanced addition subtraction tricks. And we're going to talk more about subtraction because there's more places you can make mistakes in subtraction. So I'm going to see if I can show you the tricks that as a teacher I look for in students, and I'm going to test you on this kind of stuff. So and other teachers do the same thing. So hopefully this will be helpful. Just like last time, when we had two different denominators, we want those denominators to be the same. So in this case, I'll probably just put parentheses around them to start with and realize what I need to do here to get a common denominator. I got to multiply this one by something so that it's the same as this one. And you can't actually do that, so I have to multiply something by both. And this is a trick that will always work between denominators. You can multiply the denominators by each other, and it will always give you a common denominator no matter what you have. So here, I'm going to multiply this one by x minus 1. This one's going to get an x minus 2. Now you see when I do that, they both have the exact same factors. As a reminder, you can't just multiply one part, you have to multiply the top as well. Because the only way you can change the denominator without changing the value is to multiply by 1. So I'm going to go ahead and multiply by 1 here. Again, here's my big 1, and over here as well. So I multiplied by 1 on both sides, so I haven't actually changed anything. So now we need to simplify this. You can leave the denominator factored. I'd recommend that because something might cancel out at the end here. Always have to check for that. The rest of it, we're going to simplify the top. So what I've got here is I've got a 3 that multiplies there, which is going to give me on the top 3x minus 6. And over here, this one's a little tricky, and this is one of the most common mistakes I see with subtraction problems when you're subtracting rational expressions. This subtraction sign is going to subtract everything in the top. So what you're going to have to do is this is actually a negative 2 here that's going to distribute into both pieces. Be really careful about this. Teachers look for it. It's a really common error. It's probably the most likely place you'll make a mistake on the test if you know what you're doing, because it's a really easy thing to forget. So we can go ahead and multiply negative 2 there, so that becomes a negative 2x plus 2. This negative 2 times negative 1 is a positive. So that's the numerator there. All of that is going to be over this same denominator. So we have x minus 2 and x minus 1. So now all we need to do is to simplify the numerator here, combine like terms. Remember, if you're adding or subtracting, your exponent should never change. See, a lot of students will try to add x's together and it becomes x squared. But if you're adding or subtracting, your exponent shouldn't change because exponents are multiplying numbers by themselves. So if you're not multiplying or dividing, you shouldn't change an exponent. Likewise here, this is just an x. It shouldn't become an x squared after you subtract. So I have 3x negative 2x. That's going to make a positive 1x. Negative 6 and positive 2 is going to make a minus 4. And so we look here if there's anything that can cancel out. And I don't see anything here. So this is actually going to be your final answer. You can just go ahead and circle this, and you're going to be done. And again, be careful here on this. Common denominators can be found by multiplying the denominators by each other, and you need to multiply by 1. The other trick is to remember that the negative is going to touch everything in that numerator. Alright, let's try another problem here. Alright, here's another example. Going to be some of the same issues as before. This one's a little simpler actually because they already have a common denominator. So I don't need to do anything to the denominators at all. All I need to do is combine the numerators, and this is where the issue comes in. Because again, you have a subtraction problem, which means that everything in the second fraction is getting subtracted. So all of these pieces are being subtracted, not just the 2x. The way I like to write this so I remember is I'll rewrite the fraction and make sure I put the entire fraction in parentheses. And remember, when we add or subtract, the denominator doesn't change. This doesn't become like 12x plus 12. The denominator stays the same. That's why we find a common denominator. Now if you put your parentheses here, you should see that this is actually a negative 1 that's going to distribute into both pieces, which is going to allow us to solve this question. So negative 1 times 2x is going to give me a negative 2x. Negative 1 times negative 5 is a positive 5. So this whole thing becomes negative 2x plus 5. So now we can see what we're left with. We're going to combine some more like terms here. We have a 3x and a 2x, which is going to give me a positive 1x. Be careful with that. Again, your exponent shouldn't change. Negative 4 and positive 5 gives me a positive 1. So 1x plus 1 over 6x plus 6. And a lot of people would just be done here. The trick with this one, you have to factor everything, and we actually didn't do that to begin with, so we didn't think about it. But this denominator will actually factor. You can find a common multiple here. So this is going to be, if you factor out a 6 from both of these, again, remember factoring a common multiple just means you divide it out. You can think of it as undistributing whatever that number was. So 6x plus 6 becomes a 6 times x plus 1. Don't forget the 1 there, because when you distribute your 6 back in, it should give you what you started with. And now on the top here, I have also an x plus 1, and you should see that this is going to cancel out because it makes a big 1 here. Alright, a really common error that I see my students making is they will cancel this out and say it equals 6. And that might look right to your eyes because everything canceled out here. But keep in mind, the 6 was in the bottom of the fraction. It needs to stay there. It doesn't magically teleport to the top just because something cancels out. So what I'm really looking at here with this 6 is it's a 6 over 1. When you cancel something out into a big 1, it doesn't disappear. It becomes 1. So be careful. That answer on this one should be 1/6. Okay, so this next question I'm going to show you guys is not necessarily more difficult, but there's lots of little mistakes you can make that will end up giving you the wrong answer. And there's little mistakes getting the wrong answer. That's what really hurts your test scores. So, if you can avoid these, you'll probably gain maybe 10-15% on this test just by avoiding these. So here's an example question of what I'm talking about. So here's a couple. So this one is going to be nice because you're not going to need you're not going to need to find a common denominator. Both of these already have a common denominator here of 2x minus 7. So we can go ahead and put some parentheses around those just to remind ourselves that. A couple of quick errors that I see students do all the time. So try to avoid this if at all possible. Actually, just avoid this. Don't try, just avoid this. Okay? Channel your inner Yoda. I see so many students do this. They'll cancel out something like a 2x over 2x. You can't do this. The reason you can't do this is Remember, we can we can only change the way a fraction looks if it's being multiplied by 1. In this particular case here, we're subtracting 1. This big 1 that you see isn't really a big 1. I'm subtracting it, and when you subtract 1, it does actually change your fraction. So you can't do this. The only way you can cancel anything out ever is if everything on the top and everything on the bottom is factored. If you cancel out before you've factored, you're doing it wrong, and you will get the wrong answer. Avoiding this mistake right here will save you a ton of points. You could probably go from failing to passing just by not making this error. So again, you can't cancel anything out unless everything in the top and everything in the bottom is factored. So now that I've got that out of the way, please don't make that mistake. I see it all the time. It's very, very common. All right, so let's finish this question here. So again, you don't need to worry about a common denominator. It's already there. So we can just combine like terms at the top. Notice there's a plus sign here. You don't have to worry about distributing a negative. So we've got negative 4x and a positive 2x. That makes just a 2x. Positive 8 and a minus 1. Sorry, negative 2x, apologize. And a positive 8 and a minus 1 makes a positive 7. Now many students right here would stop, circle the answer, and you'll do well if you do that. Again, your teachers probably give you lots of partial credit for doing the problem correctly. But there's one more trick here that's going to keep you from getting the right answer. And that one is this. Notice here, this is negative, but this one's positive. This one's positive, but this one's negative. The signs of each symbol are exactly switched. The reason this is important is we can actually change it. The only time this works is if everything is the exact opposite sign. So things that are positive are negative, things that are negative are positive. So what we can do with this, instead of factoring out like a common multiple of 2 or 3, we can factor out a common multiple of negative 1. So what I'm going to do here is I'm going to factor out a negative 1. Remember, we're undistributing in this case. So that means when I multiply negative 1 in, it should give me this when I'm done. So that means this has to be a positive 2x, so when I distribute it in, it becomes negative. And this one has to be a negative 7, so when I distribute it in, it becomes a positive. But notice what happens when I do that. Now I have a big 1. The top and the bottom are both factored, and I can cancel out that entire part of the question. So I'm going to go ahead and do that right here. Those both cancel out, so I end up with negative 1 times 1, which just equals negative 1. So again, be careful on that. Look for cases where you can factor out a negative 1, which will allow you to cancel out things. And don't cancel them out unless everything in the top and the bottom is factored. Alright, so we have here a whole bunch of stuff, and remember, if you don't see what to do at first, factoring is always a good choice. Both of these are going to factor. You see this one and this one here. It looks like they're going to factor, and they do. So you have to be a little bit careful about factoring them, but they do factor. So this one, again, I'm looking for two numbers that multiply to be negative 28, add to be negative 3. In this case, we have negative 7 and positive 4. Make sure your 7 is the one that's negative because it has to add to be negative 3. This one over here is going to factor to x plus 7 and x minus 5. Now, this looks really terrible at first. You start looking at this, and again, we're trying to find what the two denominators have in common. These have nothing in common. The x minus 7 and the x plus 7 might look the same, but they're actually completely different. You can't do anything to change one into the other with multiplication. Likewise, x plus 4 and x minus 5 aren't even close either. So what we're left with is a little bit of a conundrum, but I'll show you a last trick that will be helpful for you as you're trying to simplify these rational expressions. And if I get rid of this stuff up here, I think it'll be a little bit more obvious about what's going on. I'm just going to go ahead and replace this with x plus 7 and x minus 5. And I'm going to replace this one with my x minus 7 and x plus 4. Now we can look at this here and see if you see anything that you can do. Take a second. I'm hoping you guys are starting to see this. But in each individual fraction, there is a big 1 that will make this a much easier question. There is an x minus 5 here, and an x minus 5 here. There's an x plus 4 here, and an x plus 4 here. And there's absolutely no reason why you shouldn't just cancel those out right away. And I'm going to go ahead and do that. Remember, we got a big 1 here. Ooh, wow. That's a good one. And here's another big 1. There's a reason I'm not an art teacher. Anyway, so I have a big 1 here. Remember, the x minus 7 is on the bottom. It needs to stay there. So I have 1 over x minus 7. And over here, the x minus 5's cancel out. And I have 1 over x plus 7. Now, this is a much easier question. In fact, the very first question that we did in this video was really similar to this one, where we had two denominators that were completely different, so we multiplied them by each other. So I'm going to go ahead and do that again, just like we did in the first question. The x plus 7 is going to get an x minus 7, again in a big 1 format, because that's the only way I can avoid not changing the problem. This one's going to get an x plus 7. Once I put these guys in here, again, I've multiplied by 1, so try to remember that's what you're doing. It's the only way you can change the way it looks without changing the problem. Since I'm multiplying by 1 here, it doesn't really change anything. So what I'm finally left with is I have x plus 7 over here, over, and I'm going to go ahead and distribute this. I notice this is a difference of squares. You're welcome to multiply this out if you didn't see it. But whenever you have an x plus a number, x minus a number, it doesn't even have to be x. But if you have the exact same parentheses twice, but one's positive, one's negative, you can do this trick. It becomes a difference of squares. So it's going to look like that. Over here, we had a negative 1 times x minus 7. I'm going to go ahead and put that in parentheses so I don't forget that that negative is going to distribute. Remember, once I have one denominator, I don't need to add it to itself. So this denominator is the same. You don't add the denominators, just the numerators. So what I'm left with here is a negative 1 that will distribute into both of these. So I get a negative x and a positive 7. I'll go ahead and write that in. So I get minus x plus 7. Again, that's all over this fraction here. You can combine like terms. I hope you see that the x and the negative x are both going to cancel out, leaving you with just 7 plus 7. So that final answer is just going to be 14 over x squared minus 49, and that is your final answer. So again, to review, the things to look for. Subtraction problems. You're probably going to need to distribute when you have a subtraction problem. You're also going to need big ones, find your common denominators. If there's nothing in common between them, you can multiply the denominators by each other. It will always give you the common denominator. And lastly, you should look to see if something will cancel out at the beginning